So we will be discussing how to find a majority element given an array of size n. So basically what a majority element is in an array of size n, it is an element that appears more than n by 2 times, where n is the length of the array. So for example, you have an array, this array 1, then 2 appears 4 times, then 3 and 7, right? So the length of the array here is 7. 2 appears 4 times, which is exactly more than n by 2 times here, right? So when we say that an element which is a majority element, if there is such element which is a majority element existing in a given array, then such an element can at most be only one, right? So for example, let's say you have an array which is like 1 1 2 3 3, right? Let's say 2. So here you have uh, 2 times 1, then 3, then 6 times 4, and then you got 2, right? So the length of the array here is 1 2 3 4 5 6 7 8 9 and 10, right? And then 4 appears more than 5 times, right? So this sentence that at most only one majority element can exist makes some sense, that if obviously there is an element that is appearing more than n by 2 times, where n is the length of an array, then there can be only one such element, right? So in this example you got 4, right? So so the idea behind finding a majority element is there is an algorithm called Moore's voting algorithm. So the very premise of Moore's voting algorithm is like you got this you have this array which is like 1 2 2 2 3 and 7, right? So if you take any element x, let's say in this example we take 2 as an element, and if we cancel out the occurrence of 2 with every other element, let's say for the first time we cancel out the occurrence of 2 with 1, so this one will get cancelled, this 2 will get cancelled, right? So we have 2 2 2 3 and 7. Now let's say we have this 2 getting cancelled out with this 3, so right. So now we have 2 2 and 7. Let's say this 2 got cancelled out with this 2 7. So finally what you have a majority element, right, if it exists, right? So this is what Moore's voting algorithm is. So we'll try and implement a Moore's voting algorithm. So what we can do is, like, we can assume that our candidate, let's say, is the very first element as of now, and then you can hold the count. So so let's say in this example we are assuming that 1 is the candidate as of now, the current candidate, and the count is 1, right? So the very first time 1 is occurring, it occurs 1 times, right? So what we need to do is, like, we'll traverse the array across till the end of array, right? So we traverse it, we'll check if the current element, right, if the current element, which is array of I, is equal to the candidate, right? So we'll increase the count. Otherwise, sorry, in Python there is nothing such as increment and decrement operator. So we have this, then you have this, right? So now we'll check if the count is becoming 0. So if the count is becoming 0, we can be pretty sure that the current candidate was not an majority element. So what we'll do is, like, we'll assign a new candidate which will be the current element, and then again the count for that current element will be 1, and then we can return our candidate. So you have this find majority element. So what we can say is, like, voted element for more semantic reasons. Let's say it sounds more semantic. So we have find candidate, right? And we pass the same array. Now once we have the voted element, right, so we need to verify whether this voted element is indeed a voted element, For that, what we can do is like we can just traverse across the array, right? And then if uh, voided element is equals to the current element, we can increase the count, right? And now finally we can check is like if count is greater than n by 2, we return our voted element. Otherwise, we return, let's say in this case, we'll just return -1, right? So for an existing example, we should get 2. Let's try. Oh ho ho. So global name n is not defined. Line number 35, sorry. Where is n? Let's check again. Global name n is not defined in line number 50. Right, find majority element. Okay. Where is this n? Oh, okay. So my mistake. Sorry. So you got -1 because there is no such element which is a majority element in this example. We will have to add 2's. Now we should get 2. So this is how we implement a majority element. So what is the complexity of this solution, right? So for finding the candidate, whether this candidate is a majority element or not, so we just finding a candidate. So we just needed to traverse the complete array. So for that, it is just big O of n, right? And then verifying whether the voided element is indeed actually a majority element. Here we again just need to traverse the array once, so which is again big O of n, and the overall complexity then becomes 2 times of big O of n, right? Which we ignoring the constant, which is approximately big O of n itself, right? So this is how you can find a majority element in an array of size n in big O of n.